Hey y'all, in this video we're going to put together all the pieces and understand how bonding happens from the perspective of energy, and think about this in terms of our hybridization and sigma and pi bonds. Okay, so let's start fairly simple, right? So let's start with something like carbon. Well, we know carbon has an electron configuration of 1s2, 2s2, and 2p2. And all we really care about are our valence electrons. Remember, they're the ones that are important for bonding. So if we think about the energy of our valence electrons for carbon, we have our 2s electrons, and then our 2p subshell we know consists of 3 lobes that are all equal energy. And the way that electrons are populated, at least originally in the carbon atom, look like this. Okay, so that's kind of the basis for thinking about what happens with bonding, is starting off by thinking about atoms and the energy diagram for atoms. Because when carbon makes a molecule like methane, right? So if we draw this out, and I'm going to use different colors for each of my different hydrogens just so we can kind of keep track of electrons. So what we're looking at here is methane, right? And when we look at this molecule, we know that carbon has an sp3 hybridization. Remember, we can determine that by looking at the molecule and saying, okay, 4 bonds, that means 4 lobes, so spp. So in this molecule, carbon no longer looks like this, but instead the energy diagram has 4 equal lobes of sp3 hybrid orbital. Okay? And each of these lobes has a single unpaired electron, which has to be there because each of them are making covalent bonds with hydrogens. Okay? So now let's think about a hydrogen. We know hydrogen is a 1s with 1 electron in that 1s orbital. Right? So this corresponds to this blue hydrogen here. And what we note from our structure is that we have a covalent bond between that hydrogen and carbon. And as it turns out, these 2 electrons are what pair together to make that covalent bond. So this is the sigma bond between carbon and the blue hydrogen in that diagram. We think about another hydrogen, right? So let's say the green hydrogen. I have a 1s electron. This is the sigma bond between carbon and the green hydrogen. 1 electron from hydrogen, 1 electron from carbon. Let's move on to the white one. Okay, again, I have a 1s electron. A single electron is paired with a hybrid orbital from carbon to make the sigma bond between carbon and the white hydrogen. Okay, and the last one, we'll draw it a little bit differently so it's easier to see. Here's the 1s electron. There's my sigma bond, right? So there's the sigma bond between carbon and the purple hydrogen. The idea with these diagrams is that we're showing electrons and we're showing what each electron is doing. In this case, we have 4 unpaired electrons on carbon, each in their own individual lobe of the hybrid orbital, and they're all making a sigma bond with an individual hydrogen atom. Let's apply this to something that's a little bit more complicated. Okay, let's this time go and think about ammonia. Okay, so I'll keep the central atom, nitrogen, here in red, and show each of the hydrogens as a different color. Okay, so again here, we note that this nitrogen has sp3 hybridized. So I'm going to go ahead and draw that out. So it's sp3 hybridized. We know that because there's a lobe for the lone pair here, right? That requires a lobe. And then each of the 3 covalent bonds also require a lobe. If we think about what's happening with the electrons on nitrogen, nitrogen has 5 valence electrons, so we need to show what each of those 5 electrons are doing. What we note here is that one of them is a lone pair. So let's show that lone pair. There's my lone pair. okay? One of them is making a covalent bond with the blue hydrogen, one of them is making a covalent bond with the green hydrogen, and one is making a covalent bond with the white hydrogen. So let's go ahead and show each of those unpaired electrons, and each of these are making covalent bonds. So thinking about hydrogen, we know it's a 1s. There's one electron there. That's my sigma bond. All right, that's this sigma bond right here. The green one, let's just save a little time here, and this is the sigma bond with the NH, right? So this right here is happening because of the sigma bond. We're creating a sigma bond with that hydrogen. And the white one we'll show here. So there's the one electron. This is a hydrogen. It's a 1s electron. This is the sigma bond between nitrogen and the white hydrogen. So again, we are accounting for what each electron is doing. Let's look at one last example. Okay, I'm going to use the example of this molecule CH2O. Drawing out the Lewis structure of this, I have a carbon. I'm going to show my oxygen in blue. I'll show the hydrogens in green and white. Okay, what I recognize here is that the oxygen is sp2 hybridized, and my carbon is also sp2 hybridized. And of course, hydrogens can't hybridize, so they are composed of a single s electron. All right, focusing on carbon first. So this is my carbon, sp2 hybridized. So remember, I'm going to scroll up here for a second. Carbon started off like this. Let's go ahead and delete those. So the idea with sp2 is I'm taking my s lobe, I'm taking two of the p orbitals, and what I want to point out here is that in sp2 I have a leftover 2p orbital. That's important because that's where my double bond is coming from. Okay, so let's scroll back down here and write out what carbon looks like. 3 lobes in my sp2, but I also have a leftover 2p orbital. Okay, so looking at carbon, I see 3 bonds here, right? So I have a bond here, and a sigma bond here. So I have 1 electron in each of these lobes corresponding to sigma bonds. But I also have a second electron in my pi bond, and that's coming from my p orbital. So this is what carbon looks like. Oxygen is also sp2 hybridized, so let's go ahead and show it. sp2, a leftover 2p orbital, and thinking about what's going on with oxygen. I have 2 of my hybrid lobes that contain a lone pair, so let's show those. These are both lone pairs. I have 1 of my lobes making this sigma bond. There's a sigma bond, and the last electron from oxygen is in that leftover 2p orbital. Okay, so right here, this 1 unpaired electron from oxygen and 1 of the lobes of the sp2 hybrid from carbon is what's making the sigma bond between carbon and oxygen. And this right here is the second bond, the pi bond between carbon and oxygen. So together, that's both of the bonds. The other 4 electrons of oxygen are present in lone pairs, whereas the other 2 electrons from hydrogen, this one is making a sigma bond between carbon and the green hydrogen, and this one is making a sigma bond between carbon and the white hydrogen. So that's the big idea here, is if we think about the energy diagram for these atoms, we think about them in the context not of the individual orbitals, but of the hybrid orbitals. And we can think through exactly what's happening to each electron. Every time you have a single bond, that's a sigma bond, and that's an overlap between an s orbital of hydrogen and a hybrid orbital of some other atom, or two hybrid orbitals. Double bonds and triple bonds are composed of, first, that sigma bond, but also pi bonds, which are composed of overlapping p orbitals from the individual atoms.